Look at this, another example. We have open water tap here, and the water flow in this direction according to the blue arrow. And then we have a region of yellow. We also have region of brown. We also have region of light blue. It's just a region, it's nothing there. Okay? So if we could consider here pressure at 1. Pressure at 1 is actually the highest, because the water always flow from high pressure to low pressure. Water always flow because one side is high pressure, the other side is low pressure. So left hand side high pressure, right hand side lowest pressure. So because of P1 having highest pressure, so the external atmospheric pressure has not enough power to press it down. So it will be overcome by the pressure around the yellow dot. Okay? So this one can overcome more. Okay? This external pressure, the power indicated by the length, my own definition, okay, just for you to understand. You see the length is longer, so it has more power to press it down. Why? Because the water flow here is actually having less pressure. Less pressure, so this external atmospheric pressure higher, it will press it down. And then as for this green or light blue thing, the water flow here is actually the lowest pressure. It has the lowest pressure here. So lowest pressure, so the external atmospheric pressure seems to be pressing it down more. Okay? So this is because water flow from left to right, and water flows because the pressure on the left hand side is higher pressure than the water pressure at the right hand side. Okay? Let's try another example. You have this tube again with 3 branches, but one thing special is there's a narrow channel here, and the flow is from left to right. And starting point, the water has more energy, the right hand side has less energy. Okay, so generally I would call this A, B, C. Generally, comparing A and C, they have the same tube size. Same tube size, so they will flow quite slow. Generally they are slow, but I would say that C is slower, because on the right hand side there's less pressure already. So there's less pressure comparatively. Let's use blue to compare A and C only. Or should we use another color? Yes. So compare A and C only. You see A, the external atmospheric pressure press it less, because here pressure more. Okay? Here pressure more. P1 more, atmospheric seems to be less. Okay? So, and then this one on C, the arrow seems to be longer, so it's my indication that atmospheric is actually more. And at this region, the P3 is actually less. So why is this happening? As I said, comparing A and C, generally both are slow, because in a wide tube you can flow slowly. Okay, but C, because the flow of water from left to right, at the right hand side there's less energy already, so it's even slower. So if it's even slower, it has at this point of P3, the pressure is actually less, so the atmospheric will be more. It will press it down further. Okay, so as I said, water flow from left to right, energy is less on the right hand side. It is a case of low pressure. Okay, not exactly Bernoulli yet, but to compare A and B, or C and B, is a case of real Bernoulli, because you see at B the flow of water is very rapid. Just like I mentioned, A and C is not so much of Bernoulli's principle, but at B it is really Bernoulli's principle, because at B the channel is narrower and the rapid flow is there. the rapid flow is there. So we have a region, I put a cross here. Cross is a region of low pressure. You know why low pressure? Because according to Bernoulli's principle, the faster the fluid moving, the lower pressure. So X is a region of low pressure. So externally we have the atmospheric pressure pressing it down very much, because atmospheric pressure is much higher. So B is a case of Bernoulli principle, but A and C is not really so much of Bernoulli's principle, but yet is related. But comparing A and C, A is having higher pressure, C is having less pressure. Okay? So we also want to consider a case of air tube. Okay? If your air tube has air flowing again from left to right, and you know that A and C, as we can compare again, they are generally slow as written here. Speed of air at A and C are generally low. Speed of air at A and C are generally slow. Okay, because wide tube, the airflow inside is very slow. But for a narrow channel like at B, you have a case of airflow really rapidly, because it's in a narrow channel. In a narrow channel like this, it will move very fast. When you move very fast, you have a region of low pressure. Region of low pressure. When you have region of low pressure, the atmospheric pressure seems to be pressing the water so that it will rise up even more. As for A and C, again it's a case of A has higher pressure, more energy, C is less energy. So higher pressure, so the high pressure seems to be pressing the water down, and this one less pressure because lost energy already, seems to be pressing the water down less compared to C. So maybe I make a statement here. The pressure of A presses water down more than the pressure of C. Okay, you can realize this because the water level is very low for A. It presses down at A, the water level in A. But as for C, the air pressure in C is pressing less, so the water can be higher. But then again, B is a case of very strong indication of Bernoulli's principle. Okay, so it's rapid flow in a narrow channel, so you have a region of low pressure. The outer pressure indicated by this curved arrow seems to be pressing the water in and rise up the water level.